Hello and welcome. Now in this lesson we're looking at static electricity. Let's just look at the aim. Aim to explain the role of electron movement in charging an insulator, state that light charges repel and unlike charges attract. I'm going to start by looking at some examples of static electricity. Some of these you may have come across. So this one's a classic example here. This is the balloon sticking to the wall. And this is the comb picking up little bits of paper. This is an amazing one. This is what's called a Van de Graaff generator. I'll explain how it works a bit later on. But if the hair is very, very fine and the day is nice and dry, you can get some classic effects like the hair. I've never seen one like this before, but pretty impressive. This one is plasma balls. You can see these in science museums. You put your hand on the side, so you put your hand over here, for example, and it tracks the plasma. Amazing thing. Don't know how it works, but bit of research there for you to find out. So, what is causing the balloon to stick to the wall? What I've done a little sheet for you here, so you may want to print this out, and on this you can put the notes as we go through it, so you could actually have it as an A4, or if you have the facility to make it A3, even better. So there you got a little worksheet there to fill in. Okay, now there are only two types of charge. There are what's called positive charges, and it's the protons in the atom that have the positive charge, and protons are found in the nucleus. The negative charge is the electrons, and these are orbiting around, and they can be brushed off onto other atoms, making ions. The neutron, also in the nucleus, has no charge at all. So you've got proton positive, electron negative. So if an object is positively charged, it must mean it's got too few electrons. So electrons must have been transferred. If it's got negative charge, it must have too many electrons, so it must have gained electrons. So net charge is always due to electron transfer. So whenever we're talking about static, we are talking always about electron transfer. If you gain it, then you're becoming more negative. If you lose electrons, you're becoming more positive. So net charge, it says down here, net charge is always due electron transfer. You couldn't have protons moving, because if protons moved out of the nucleus, you'd actually change the element you're dealing with. This is common knowledge, I hope, in that opposite charges attract, and you won't be surprised to hear that like charges repel. Now we can make something charged by the action of friction. So static charges can be produced by the action of friction on an insulator. So here we've got a rod. It could be made out of plastic, amber, glass or perspex. All of these are insulators. What you would then do, you'd rub the rod here with a cloth, for example, and that cloth has the what happens is the electrons get rubbed off or rubbed onto the insulator. Okay, so objects are positively charged by loss of electrons. So as the cloth is rubbed along the rod, okay, it picks up electrons. So rod becomes positive because it's lost electrons. The cloth becomes negative because it's gained electrons. Not quite sure what happens to the dog there, but there we are. We'll move on. So objects are charged negative by the gain of electrons, and this gain is what we call electricity. So only electrons move. That's what they call it, electricity. This is, I promised you earlier, this is a diagram here showing a Van de Graaff generator. Okay, if you're in school, you've probably seen one of these, and it's everybody's favourite. So you've got a belt. What happens is the belt here revolves around the rollers. So you can either use a handle to wind the belt round and round, or you could use electric motor as you've got here to get the belt moving up and down. Now you've got also down here a brush. Now the brush rubs against the belt. Electrons are added to the belt, okay, and there's work done in moving electrons. I've lost that bit there. Okay, creating high voltage. And what then happens is that you get a charge accumulating on the dome. So if somebody has got very fine hair, they can put their hand on top of the dome here while they stand in an insulator, and if they've got very, very fine hair, their hair will stand, because the hairs, each individual hair becomes negatively charged Like charges repel, so the negative charges repel. The hair tries to push away from the hair next to it, and this is why it stands on end. And I've seen people use this to light Bunsen burners with. Okay, they hold one hand on the Van de Graaff generator, they turn a tap on a gas tap, hold the hand near the Bunsen burner, spark jumps, and you can get very impressive reactions, but not one I actually recommend. Okay, so there's a Van de Graaff effect, and this is, say, one of the best I've ever seen. I've personally never seen a hair go like that. That's quite amazing, isn't it? Okay, so how do we measure static charge? What we use is something called a gold leaf electroscope. Now, the gold leaf electroscope has got in it a very, very fine gold film. Okay, gold leaf there. Now, here's our charged object. It's brought close to the electroscope. What happens is the charge passes down into the electroscope here. Now, these positive charges repel, and the bigger the positive charge, the more the leaf will repel. So what use is electrostatics? The first one is helping us with the environment. So this is, for example, a chimney in a coal-fired power station. So number one, smoke from coal contains soot particles. As those soot particles pass through this negative charge here, this grid, they become negatively charged. So soot particles touch wire and become negatively charged. The plates at the top of the chimney are positively charged, and the negatives, therefore, these are soot particles here, get attracted to the positive. Therefore, we've got cleaner smoke which can be emitted to the atmosphere with fewer smoke particles. So that's one way of protecting the environment. Photocopiers. Photocopiers, never knew how these worked. Well, what happens in a photocopier is light causes the image to have a positive charge. Okay, the toner that goes into the photocopier has got negative charge, and this attracts itself to negatively charged image. The image is transferred to paper. That should be positive, shouldn't it? I'm sure that should be positive. Negative charged toner sticks to positively charged image. Yeah, that's a mistake there. Excuse me for making a mistake. Image is transferred to the paper, and finally the image is fixed by heating it, which is why your photocopies always come out nice and warm. Paint sprayers. Okay, so this is a way of reducing two things: reducing wastage of paint, but also it makes sure you got more even covering of the paint. Sorry, it's a bit out of focus. The advantages of using charge is less waste as negative particles of paint attracted to the car. So what happens is, as the paint passes through a negatively charged nozzle, the paint itself picks up a negative charge. The car is positively charged, and so less waste as negative particles of paint attracted to the car. We just said that. But secondly, more even coat as each particle repels its neighbour, so you don't get runs of paint on the car. Now, static charges can be dangerous, as shown here by this car. I don't know if we can pick up the clip. Let's see if we can pick up the clip. So what we've got here is this lady in the petrol station here. She's filling up. Wow. Impressive, huh? But that'd be a panic moment. She's very cool and calm and collected about it. I'll be panicking, I think, more about that one. So that's what the danger is, could be in that. So that's the dangers. Okay, and also this is why when planes are being refueled, the tanker here holding the fuel has to be earthed, because if a spark occurred while the tanker was filling up an airplane, there'd be a massive explosion. Okay, which is why therefore these tankers are earthed. So a few questions for you. These objects, are they positive or negative? Have they lost or gained electrons? You can work that out for yourself, I'm sure. Will these attract or repel? Again, you can work this out for yourself. And why do balloons stick to the wall? This is the first question we had, wasn't it? So a balloon can be charged by rubbing through the hair, which is positive. Well, electrons are being rubbed off the hair, so I'm guessing, yes, the hair is left positive, therefore the balloon must be, what was it? This is the balloon before, this is the balloon after. So what's happened to the balloon? To me it looks as though it's gained negative charges. The balloon is more negative, I was quite right. Remember, electrons can move, the negatives on the wall are repelled and move away, leaving positives which attract. And so we see in this final slide that the positive and negative are together and the balloon attracts or is attracted to the wall. Okay, well thanks for watching and listening, and I'll be back with another lesson very soon. So bye bye for now.